All right, so in the last video, we were looking at the beginning of 7.1. Now, what's going on with 7.1 is we're looking at how to solve triangles that don't have a 90-degree angle in them. So we can't use the SOHCAHTOA or the Pythagorean theorem on these. And 7.1 deals with the law of sines, which can be used in some cases. And when it can be used, it works really, really well. So we looked at a couple problems there. You ought to look at section 7.1 in the book, kind of read through that, and then I just worked out the checkpoints here for you. All right, so the two examples I did, one of them is a situation where you have two angles given to you and a side that's not the one that's included between them. Okay, so that situation is sometimes called the angle side, or for some reason in this book they call it side angle. But like in your geometry classes, you probably learned it as angle side. All right, and then on the second problem, they gave you two angles and a side, but the side was the side included between the two angles they gave you. So that situation is angle side angles, it's sometimes called. Okay, so those instances, you have exactly one possible triangle. Everything works out nicely. Okay. What we're going to look at now is when they give you two sides and an angle. This is sometimes called the ambiguous case. Okay, because you might have no triangle, really. Maybe the information they gave you doesn't really form a triangle. You might have one triangle, one and exactly one, okay? Or you could have two triangles, and it just kind of depends on the given information for which situation you're going to wind up having. All right, so I normally don't figure out ahead of time whether I'm going to have none, one, or two. I just go ahead and work the problem to the best of my ability, but I just reason out whether there's more than one possibility or not. Okay, so let me show you what I'm talking about. So let's suppose you had a triangle and you knew that angle A was 50. I think I'll go ahead and start on a new page here. So angle A was 50 degrees. That's big, too big for 50. Okay, so maybe like that. All right, and then I have side A, so that would be, if this is angle A, side A would be opposite that. And then side B, okay, so side B, if this is angle B, this is going to be side B. So I know side B is 20, and I know side A is 10. Okay, so I really don't know right now whether I get a triangle out of this or not, but this is kind of the picture I'm thinking about. And then sometimes you don't get just one triangle, you get two triangles, because maybe it'd be possible to swing this over here and have a different triangle that also has side A being 10. Okay, so here's what you do. Okay, try to get that to go away. Right there. Why aren't you going away? Okay, so let me get that drawn again. So that's the given information. So I'm thinking about trying to solve the triangle. I know angle A is 50 degrees. I know side A is 10. I know side B is 20. And then don't know the rest of it. So if I'm going to use the law of sines, then I want to have this for one of my ratios. Okay, so I'm going to have it equal to, and I'm going to put that as one of them. Now, something that's different here is what I'm looking for is an angle this time. So I'm going to set up a proportion using the A and the B's. And what I need is the angle. So this might be a good time to flip over the law of sines and put the angles on top. So I'm going to do sine B over little b, okay, equals sine of A, which I know is 50 degrees, over little a. And so I like my unknown to be in the top left corner. So this one is going to involve a little more work. I'm going to multiply both sides by 20. So the 20s will cancel out. I'll have sine of angle B. Okay, I could, if I wanted to, simplify over there, or I could have just done sine 50 times 20, but make sure the 20 is not inside with the 50. So I'm going to do 2 times sine 50. Okay, or I'm going to do 20 times sine 50 divided by 10, either way. And what I get is that the sine of angle B is about, and I'm going to keep, a good amount of accuracy here. I don't want to drop too many places. So keep like 4 at this point. This is not the final answer. So keep a bunch of accuracy on that. Okay. All right. But now I would want to find angle B. So that means I would have to do sine inverse of both sides. Okay. To undo the sine and get what the angle is. Now watch what happens when we do this. If you try to do inverse sine, so second function in the sine button, and put in a 1.5321, your calculator says domain error. Okay. All right. If you think about it, if you think about the unit circle, your sine values never get to be more than 1. Okay, so this is the spot that has the biggest sine, and that ordered pair is the ordered pair 0, 1, and the sine never goes above 1. That's also true for cosine. Cosine never gets bigger than 1. So you're getting an error because this is impossible. Okay, so not possible. So since you don't have an angle B, this one is no triangles formed. But that's what happens, okay? So that's that case, and this was checkpoint 4. Checkpoint 4. Okay. All right. Now let me back up a minute and let's look at checkpoint 3. Okay. So on this one, A is 57. Okay. Then I know little a is 33 and little b is 26. So I know b has to be less than 57. So little b is 26 and a is 33. Okay. All right, so let me see if I can clean that up a little bit. All right, so that's what we've got. And I always have to double check that I've drawn it, it looks okay, that I put things in the right spot. Okay, so we're trying to find A, B, and C, and then little a, little b, little c. And they gave us little a, they gave us little b, and they gave us angle A. Okay, so our job is to find all the rest of these. All right, so again, we know that we can use the proportion that has the A's in them. And then we know the B is 26, so we'll use it. This is the unknown, so I'm going to put it in the top left corner. Sine B over the length of side B should equal the sine of 57 over 33. 57 was angle A, 33 was the side opposite that. Okay, so we'll multiply by 26 here on both sides. You can simplify when possible, but you really don't need to take the time to do that. You can just type in 26 sine 57 and divide that by 33. Make sure you're in the correct mode, and you get that the sine of B is about, and I usually at this point keep at least 4 decimal places of accuracy so I don't lose. I don't get round off error. In fact, on my calculator, I keep the whole thing sitting there, but I just don't feel like writing it. So now I'm going to do inverse sine, and I like to use the feature, the little ANS. So I do second function in the minus sign, which brings up the previous answer, which has more decimal places than I actually used here. And if I round to the nearest tenth, I didn't check to see how they wanted this one rounded. So I do think we're going to be rounding to the nearest tenth on this. No, the angles, it looks like we round to the nearest whole. So angle B turns out to be about 41 degrees. So on that one, we're going to round the angles to the nearest degree and sides to the nearest tenth. Okay, so I just found this one. It's about 41 degrees. And so while I'm working with the angles, I could go ahead and do 180 minus the 57 minus the 41, or I could add up the A and the B and subtract that from 180. And that tells me that C is about 82 degrees. And so now I like to use the given information. So I'm not going to use the B's in the proportion. I'm going to go back in and say, okay, well, little c over the sine of 82 would equal little a over the sine of 57. Okay. And then you're going to multiply by the sine of 82 on both sides. Okay. 82 degrees. Okay. So that knocks out the sine of 82 and leaves you just c on the left. And then I'm going to type that in, 33 sine 82 divided by sine 57. And I get C to be, when I did it, let me keep a little more because this is a tricky one to round. I got 38.965. So if I'm going to round to the nearest tenth, because that's a 6, I would bump that up 1. But when I do, that's going to bump that to be about 39. Okay, so the rounding was a little tricky on that. So C was about 39. Okay, so there were no apparent issues on this, but I do need to comment on something that I didn't do on this one that I should have. You've got to be careful when this part right here, okay? Sometimes, like we found on this one, when we tried to undo the sine of B to get what the angle is, in that case, we got a situation that was not possible. B couldn't have existed because when you do the sine of an angle, you're going to get something between 1 or -1. Okay, so you didn't get a triangle. All right, but something that you've got to be thinking about right off the bat is maybe there's another triangle that would fit this same information, and we need to check on that. And where it comes from is right here. And this is really tricky to understand, but I need you to understand it. So I need you to think about the sine, right? So think about a coordinate plane. So B is 41. Well, that's an angle about right here, isn't it? And the sine is connected to the y coordinate, isn't it? If we create a unit circle and we look at a unit circle, the sine would be that 0.6608. It would be the y coordinate if this were a unit circle here. I didn't do a very good job, but imagine that, okay? Well, there's another angle. Let me try to draw that circle better. There'd be another angle that would also have a sine equal to 0.6608. Your calculator only gives you the one that's in the first quadrant. It only gives you the acute angle. You need to see whether this is another possible angle you could use. So you have to think about your reference triangles and see how that's 41. Well, this angle over here, this amount right here is also 41. So if I back up from 180, 41 degrees, if I take 41 away from it, this angle right, let me do it in blue, right here would be 139 degrees, okay? That 139 degree angle, why couldn't that be B? Maybe that's B, okay? So you have to think about whether that's possible. Could B be 139? Well, if B were 139, we were given that A was 57. Could B really be 139? Do you see how the 139 and the 57 would be more than 180, it'd be 196 degrees. That's too much. So the 139 is really not a possible case. So you only have one possible case, and it's this right here is the final solution, okay? B can only be 41. It can't be the 139 because then you'd have 139 and 57 being more than 180. But that's the hard part right there, is that there's more than one possibility for the angle, and you have to see if it's possible to use that angle and form a second triangle. In this case, there was not. And in checkpoint 4, we didn't get a triangle at all, okay? So let me look at a case where we get 2 triangles. So this is checkpoint 5. Okay, let me find it. All right, so here it is. We got angle A being 35 degrees, okay? We know the side opposite it is 12, and we know B is 16. So B has to be a little bit bigger, or it has to be bigger than that. So I'm going to draw it a little bigger. Here's my A, here's my B. The side opposite the A was 12, and the B is going to be 16. So my initial drawing might just show that, okay? All right, so now I'm thinking about finding all the rest of the angles and making sure I can get all the sides. So I know little b is 16, I know little a is 12, and I know the angle A is 35 degrees. So I start off by forming a proportion using these two. And I'm looking for the angle, so I'm going to write it with the angle on top. And I like my unknown in the top left corner. I think you'll find it a whole lot easier. Okay. All right, so we're trying to solve for B. So we're going to start by multiplying by 16 on both sides. You could simplify 16 over 12, or you could just let the calculator do that work for you when you type it in. That doesn't matter. So we're down to where we have the sine of B equaling, and let me say approximately equaling. So let me do that now. So let's do 16 sine of 35. I'm going to divide that by 12, and I get about, I'm going to keep 4 decimal places just so I don't have too much round off error, be 0.7648. Okay, but now I need to do the inverse sine of both sides. So I need to do sine inverse. Okay, so that'll give me B, and it'll be about, and I'm going to go in and do second function sine, put in the 0.76 or bring up the answer from before. And I get that B is about 49.9 degrees if I round to the nearest tenth. All right, now here's the thing though. This is where I really need you thinking about it. So if we were on a unit circle and we're at about 50 degrees, 49.9, and we've got our unit circle, so this is a radius of 1 here, then what that 0.7648 is the y coordinate. Sine is associated with the y coordinate. It's positive. You see that? So that's the acute angle having that sign. That's what the calculator gives back to you. What you have to realize is that here's an angle over here that has the same y coordinate. Well, these would be the same. So this sign would also be 0.7648. So you need to know not just the 49.9 degrees right here, but you need to check whether this angle would also work. And so you're going to take the 180 minus 180 minus, because see how this would be 49.9 right here? So I'm going to do 180 minus 49.9. And that tells me that that angle would be 130.1. So here's where you think about whether that would be possible. So I could use 49.9 here, and then I would have, and that would be approximately, and then I would have some measurement left to find my C. My C would be 95.1. But what I just found down here is that if the A was 35 and the B was 130.1, I would still have the ability to form a triangle, because I could let C be 14.3 degrees. You see that? So if you were solving case number 5, when you got this angle right here and you check it, B could be 49.9 or B could be 130.1. So you have to solve both possible triangles. All right, and what's happening is this side that's 12 could have been over here. Okay, so this triangle would be going with the picture of the obtuse triangle, the little one on the left. And then the 49.9 would be if you use the whole thing that I originally drew. So either this being 12, this being 12, all of it the same. It's just that 12 could have been swung over here and it would give you an obtuse angle. So your job is going to be to solve both when it's 49.9 and then also when it's 130.1. Okay, so we were given the 35. We were given the A equal 12, so that's still in there. We were given the B equals 16. So all we have left to do is find a little c. So go back to your given information. And then the side C is what I'm looking for, so I'm going to put it on top. Equals side A over the sine of 35. And I'm going to work that out. So I'm going to multiply both sides by the sine of 14.3. Okay. And I'll find out that little c is approximately equal to little c is about 5.2 if I round to the nearest tenth. Okay. So it can be just a little short piece, or it could be much longer. I didn't finish that one, I realized. So let's finish that one. Let's use the B being, or let's use look for the C on this one. I need to go back and do that. So let's find the little c. Here should be much longer. Okay, so I'm going to do 12 times sine of 95.1. And then I'm going to divide that by the sine of 35. And there, the little c would turn out to be about 20.8. Okay. All right, and that remember I multiplied by sine of 95.1 on both. Okay. So do you see how the angle B could either be an acute angle or it could have been this obtuse angle? So it could have been either the 130 or the 49, which caused angle C to be two different things. Okay, so you have to solve both possible triangles and get all the parts of both of them. So here's one full solution to one of the triangles, and it's this guy. And then here's the other full solution, and that goes with this triangle. Okay, and that was when B was just 49.9. 0.9, where here the B was the 130.1. Okay. All right, so that ambiguous case really can be somewhat tricky. All right, we'll do some more where we look at both 7.1 and 7.2 at the same time, and we'll go through some more. But I just wanted to run through all three cases with you. Okay.